In-room is muted.
The ARTEMS example, it's an open source real-time operating system established in the 1990s. As a single core version, we have the symmetric multiprocessing developed since 2015, and we have the European ECSS pre-qualification for Class B now recently developed, so in the last 2-3 years. It's a widely scalable RTOS with a very low small memory footprint. It can run up to 24 core machines. We have 200 BSPs for more than 20 architectures, file systems, libraries with a good code quality, and used in many industries. And we have professional services for community and community and user support available, like from OER or from Embedded Brains or others. The funding of open source software so far has 3 sources, or can have 3 sources. We have a lot of individual contributions, so developers provide code extensions and patches on their own. We can do some crowdfunding, shared funding of suggestions which find enough sponsors. If you have a larger idea and you can't do it on your own, that might be an option. Or you have a sponsoring by foundation or a sponsor, that the strategic funding by organizations with a vested interest takes place. So if you want to fund something for an open source software, you need to do it on yourself or to organize sufficient support for your suggestion. The other attribute of open source software is that all contributions are made public. This is very useful for supported type of software, like an operating system, what is probably not that much core knowledge of an application developer or a company that uses it. Of course, there's always the risk of indirectly supplying competitors with core know-how. That happens in a commercial environment frequently enough. Now coming to the qualification, what is the difference between, let's say, certification, qualification, and codes development in an open source environment? We have to consider huge complexity and the huge effort that comes along. First, we have to consider different standards for different application domains. They have some similarities, but in detail are different. We often need a guided development process. We have sometimes exemptions for retrospective qualifications, like we had in ARTEMS, because the ARTEMS was existing since quite a while when we started with the qualification. You need the requirement specification, extensive documentation of the software and the development process, traceability tables, comprehensive testing is required with code and branch coverage, MCDC and unit tests. We talked about that during the day a couple of times. And we need a quality assurance and maintenance processes to be documented in practice. And for higher level qualifications, we need an independent validation and verification, so an independent and external review. Just to get you an idea what that is, for the ARTEMS Class C on an Xilinx UltraScale Plus we did recently, the data package is about for the qualification. The data package is about 350,000 files, and the documentation is about 25,000 pages in PDF. That is quite a mass. Another challenge of the qualification is the variety of technologies we have. For ARTEMS, for example, we have many processors and BSPs. That's not one qualification, and we have it. We have a lot of drivers that are over and above depending on hardware. So a driver is not a driver, but it depends on the hardware. And we have complex interfaces. So the qualification efforts for features often exceeds the effort for the core software by far. Each configuration would need to be qualified individually because we have interactions in the system, so we can't do that step by step or blockwise. And the general experience with all kinds of qualification or certification, that the effort increases exponentially with the complexity of the software. So some features or complex software are almost impossible to qualify. Another challenge with qualification is the dynamics, particularly with open source. Open source is maintained by a community of volunteers with many different configurations, many patches and updates, so that's a very vibrant, dynamic software, and it should be, whereas qualification is a labor-intensive process to be integrally performed for a set software package. So this is traditionally more rather a static process, and that contradicts to each other to some extent. We went out of that to some extent with the most flexible and efficient qualification process using automated testing and document generation, and the tool chain and test suite aligned with the OS community. I'm coming to the details a little bit later on. Still, a challenge is the code for qualification should be based on the mainline, but it's quite difficult to hold that while the baseline is always changing. So we have to consider this, but keep it aligned, because otherwise we have a qualified version and a mainline version that are not compatible, that separate from each other, that can't be a solution. Another challenge for qualification is the maintenance. So the qualification standards require updates to consider recently identified bugs. So we need to consider code and tool chain of software updates and patches to be considered. Just an example, the GCC, we have several hundred bugs reported annually. You have to keep an eye on that if you want so. Hardware bugs also need to be considered because they may have an impact on software. So it's not that you have a static qualification. Basically, you have to maintain the qualification properly, and that's a piece of work that can cost you a few headcounts in your company, easy going if you want to do it on yourself. So we have to need a continuous monitoring required to filter such updates and patches. And we have a laborious maintenance or delta qualification if you consider all the different versions for processors, BSPs, drivers, interfaces in the case of an RTOS. We had in the past a few attempts of having a private qualification and keeping that in a company, but all attempts, as far as I know, have ceased sooner or later for that reason. They couldn't be maintained. That was too much of an effort. Just a quick look at the automatic tool chain I mentioned in a slide before. The requalification, if you don't, you have to do that for all code changes. So just the list of tests and the list of activities here. I'm not going through the details. That needs to be done for any code change, and that's quite a piece of work. We did that with an more or less automatic tool chain development. I'm going to explain how that was funded later on. That more or less creates from the requirements, starting from the requirements to running the tests and providing the qualification documents in a mostly automated tool chain. That is a huge effort to bring in, but it worked out in a way that we can create now new qualification data packages or delta qualifications with a reasonable amount of effort. So that was quite a big step. I'm not going too much into details on that. That's a presentation on its own. The same as using the use technology, just a list what different technologies are behind such a tool chain. It's not a simple piece of software, but it's rather a complex arrangement that also needs to needs some competence and some experience to be used. And this is the point I will come back later on. Because it's not an easy piece of software that you just pack out, you unzip it, and you get it going. People are astonished that they spend weeks and weeks just to understand the concept and roughly what's going on there, as a matter of fact. The qualification challenges. What do we have? The technology, it requires a huge effort for the initial qualification. The core items was more than 10,000 hours of labor to get it qualified. And we have a large variety of qualification objects and variants for the different processors interfaces. So for RTEMs, that would be another 10,000 to get estimated 40,000 hours of work. And I mentioned the regular maintenance required that easily is more than 1 FTE. We have also to consider the economic conditions and constraints that we have in this context. Qualification is often considered after a project has reached a certain level of maturity. So initially we use the software, we like it, it works. And then earlier or later, if you want to get a mission equipped with it, we look at qualification, and then the problem may start. And we have to consider that in a real world, users normally compete with each other. So there's not only a familiar thing, but we have different competitors. So the one who invests a lot in such a software doesn't want a competitor to use it for free. Yeah, what is the principle of open source normally? The funding options that we have, also 3 different options we have considered. The open source funding is quite tricky because there's no single party being able and willing to settle the initial effort. You need a lot of special competence, and only few people and supporters, maintainers can provide that. And who's willing to review it? Also a problem that we have that we currently have. It's quite tricky to review such a qualification system. I mentioned that potential contributors are not willing to indirectly support competitors. And for crowdfunding, the initial effort is massive, particularly to satisfy all individual needs of the sponsors. If we make the qualification a commercial undertaking, we have a huge investment, means it's expensive and has complicated licensing as a consequence. Might be cost per unit or whatever, how this licenses. We have a huge investment, so it's a risky business decision if we want to make it commercial. And the business model is probably the most important reason. The business model is incompatible with open source approach. Yeah, so the advantages of open source software may be very much compromised if you have a commercial license for the qualification then on top of it. We have the option of an initial funding by sponsors. If we can convince someone to fund the initial thing, often what we have with parastatal or bigger agencies that the maintenance and continuous support is difficult to organize. We have that problem here very much. So the funding approach that we had used for ARTEMS, or that has developed for ARTEMS, it was not really intended that way all the time. We had an initial funding by the European Space Agency, who has a vested interest to support startups and small business with a qualified ARTOS at low cost or no cost. Yeah, but they have no sponsoring options for continued support and maintenance. So there's a once-off payment, and then it's it. Yeah, because they have no regular budget. So what we have is the free initial package with minimal features for 2 common controllers. The Geissler GS712 RC and the Geissler GS740 in single core and multi-core configuration. That was an investment for about $2 million from the ESA to get us started, and it included more or less this kind of tool chain that I have shown before. And then we have now to consider for the extension service maintenance, so getting the drivers in, getting different processors considered, all that kinds of things. We have commercial service providers like Embedded Brains, or we have a sponsor adding it to the free package, or you can do it by yourself. So that's the current situation. What we offer on top of what ESA is offering here, that's our approach. We call it ARTEMS turnkey solution, that we use the open source, additional software, whatever, and provide it in a kind of turnkey solution with adaptation, tooling, testing, maintenance, for anything that is between the hardware and the application software. So we start with initialization, bootloader, BSPs, security layers, operating system, abstraction layers, and the qualification package. So we make it one package out of that based on the open source software. So basically you can do it also by yourself. We just suggest it to do more efficiently by someone who's experienced with that. Yeah. But customers only pay for the individual setup, the maintenance service, and the individual additions or modifications. They're not paying for the open source software, of course not. Yeah. We have to add a cost-sharing model for non-public QDP extensions because they can't pay back for the first customer. That's simply not realistic. Yeah. If we make the first customer pay the whole development of a QDP extension, that wouldn't work. So we have to share it among different customers and pay that back. So there is a bit of a commercial piece of it, but at the bottom line, it's at a fraction of the cost compared to a commercial qualification package. So the idea behind that, a little bit shortened down, is the concept that we have on the one side an open source software with its free and liberal licensing, but you need experience and having engineering required. On the other side, there's commercial software with good functionality and delivery, what is expensive and dependency on suppliers. And with our service packages, we basically try to bring that together so that you have, as a consequence, the quality of a commercial software at much lower costs and with the independence of an open source software. So that's a little bit the philosophy behind that we are trying out, if that may work with the qualification. And what we offer, just to get you a little bit in insight, we offer SDKs with the tailored BSPs and tooling set up, maintenance subscription and engineering support so that users can have it complete. And we do the same for the qualification data package as an option. So we have 2 lines of products at that level. The qualification data package considers then from the check of the hardware until the compilation to a consistent QDP with all documents all tested as a complete package at the fraction of a cost of a commercial RTOS qualification kit. To conclude, open source software is widely appreciated for its transparency and independence. Safety qualification is a very labor-intensive and complex exercise that does not match with the established funding schemes of open source software. That's at least our experience. What we have is supported by the European Space Agency, implemented a mixed model of a sponsored, means free, and a commercial service part to have this all together. This allows to make use of the advantage of open source while providing comprehensive service to the user at very reasonable cost. And we still have the alternative option where one can do everything on your own. It's not that that we keep things exclusive or make things exclusive. It's just the service to use open source software in a professional environment. We start with this experience, with this journey. Since a few months we started, and so far it works quite well. Of course, for some users that is still an expensive exercise. They prefer going on their own way. But for many commercial users, they recognize it's not their core activity to maintain an operating system with all that kinds of things. So they order the service and enjoy the open source options that we have along with that. Thank you very much. Here are some links if you want to get more details on this concept and on the availability also of the qualification data package from ESA. Thank you very much.
Any questions?
Clint Frederickson here. So if you identify bugs or problems during the qualification process, are those bug fixes put back into the open source version, or is that kept as a separate patch set?
No, it's going to be in the mainline. We have put it back. So also the mainline benefits from this quality. Right. So we had, for example, code coverage for the initial Artemis version. Where we started with 95% code and branch coverage. Then we went to 1995, 97, 98. That was quite quick. And then it took quite a long way from the 98.5 to 100%, or 99 to 100%. That's a long way. But it is all included into the mainline. So the quality of the mainline also improves. And our experience with industry customers, for example, they love to have this software, even if they're not in the space domain, but it's space graded. They love to have the quality of the software, so we feed that fully back. The code is completely the same. Right. Apart from the fact that the qualified version has the challenge that the updating is not that quick sometimes, like the patches in the main line. That's a matter of fact. So we have to keep a certain line because we can't update the qualification data package every week.
And do you do the updates change by change, or do you batch together some amount of time or some number of changes and then requalify?
That's quite a pragmatic way of doing it. As it comes, it may be both ways, but we have to consider that the patches need to be reviewed. And the review process is a different story. So that if you put too much in one package for a reviewer, that's not going to work. So we have to go step-by-step approach every now and then to get it through. Also, frankly speaking, sometimes the review process takes longer than we expect. that needs to be balanced a little bit. But the certification process anyway is a slow process. The certifier is not going to do that within a few days' time. See the sheer number of documents. We have to be careful with the frequency of updates because they don't want to do too many updates. So practically it works with some ripples a little bit in time and the timeline.
Very good, thank you.
Thank you. I was going to give a shout out to, if anybody's here from the West Virginia facility, one of the early contributions to this was actually from Scott Zemerick at a flight software workshop, who went through all existing RTEMS documentation, compared DO-178 with the NASA space, with the ESA space, and he basically said, you're using open source terms, but you already have most of the documentation. And he gave us an outline and showed us where in our documentation to pick up existing content from. And that is now the software engineering guide, which has grown enormous. And we realized we hadn't documented a lot of decisions over the years, which we've documented now, but there's been a lot of people who've contributed to this.
Yes, I should have mentioned that. Sorry for that.
No, that's all right. He gets forgotten because it was just an outline, but it was a lot of work after his outline.
Thank you. There is one more question online. So what is the average turnaround time for a new version of the qualified version? And the second part is, in your experience, what is the biggest bottleneck along this process?
Time, that depends on what is available already and what needs to be added. The delta qualification that can reach from a few weeks to a few months, let's say. It can be half a year if that's really extensive. Yeah. What was the second part of the question?
What is the biggest bottleneck in the process?
Getting code and branch coverage to 100%. That's the big thing that you can't anticipate properly, particularly if you have complex pieces of software. Yeah. So if it's just a delta qualification, small patch is not a big thing. We get it. Yeah. But for example, for a driver, a new driver, space wire, or whatever, we can't take out of the shelf, or we have problems with the specific hardware that doesn't work as expected. Yeah. This can be very laborious, and the difficulty is that we can't anticipate. We anticipate the effort for a driver, and then we run into trouble, and then it gets massive. This is the tricky story, particularly if there's more complex drivers. I don't want to talk about Ethernet stacks or whatever. That's anyway a mission on its own.
Thank you very much.